quite intuitive how an older vehicle requires more maintenance than a new one. And the same is true for aircraft. Usually an aircraft has low availability rate when it is very young. The ground crews need to acquire experience, the logistic chains are being established, and the whole sustainment machine is starting up. Then the availability reaches a level which is more or less constant for a couple of decades when everything is running smoothly. All aircraft, though, reach an age when progressively more components reach the end of their useful lives. They will need to be replaced, adding more work to the already busy schedule of the ground crews and the depot. The readiness decreases as the airframe spends more time being repaired. The kiss of that is structural fatigue. The structural components, after taking years of punishment, start showing signs of reduced resilience and become prone to failure at loads lower than the design loads. Small cracks start forming, compromising the structural integrity. The aircraft could still fly, but it can maneuver aggressively, it can carry the full loads, and so on. This problem can indeed be reversed. The airframe can go back to 0 hours if the structural components are replaced. To do so, the aircraft needs to be almost completely disassembled and reassembled. It is a long and expensive process that keeps the airframe away from the flight line for many months or even years. No wonder that the readiness in this case plummets even further.